Hi, let's say you want to have full control over your data. You want to choose how to classify it, in what ways to classify it, how many classes to create from your data. You want to be able to have full control over whether you want a dot map or a pie chart map or a choropleth color-coded map or a graduated symbol map. In short, you want to be able to have full control over how your data is displayed so you have the maximum power possible in which to analyze it. Well then, what you want to do is to bring that data into ArcGIS Desktop. ArcGIS Desktop allows you to have full control over your data. You'll be able to classify it, symbolize it, and analyze it using a variety, hundreds of spatial tools at your fingertips. You'll also be able to analyze the attribute data. That's the I part of GIS, the database behind your maps. Let's talk about and demonstrate how to do that. Okay, let's get started. Here I have a new session of ArcMap. ArcMap is an application inside ArcGIS Desktop. I'm going to add some data with the plus sign. How about some historical data by state? I'm going to add states, rivers, highways, federal land, and cities. How about Canada and Mexico as well? Great, there's my data. Now I'm going to symbolize that data. First of all, any one of these layers can be turned off or turned on, as I'm doing here. They can also be reordered, so if I want to, I can drag federal lands over states. Now I see the distribution of federal lands and the distribution of highways. To change the symbols, just click on the symbol. Maybe I want those highways to be a 1 thickness and red. Done. Let's summarize what we've done so far. We've added data with this plus sign. We've added a set of data containing 1, 2, 3, 4, 5, 6, 7 layers. And we've also symbolized these data layers and just by simply changing the color. Like this. Great. Now what I want to do though is symbolize the data differently. Not just one color for every layer, but different colors depending on the attributes of those layers. So let's start with states. This is the G part of GIS, the map. But there's an I part of GIS. If I go ahead and open the table, I've got a whole series of data here. In this particular case, I have 51 polygons, or state equivalents, 50 states plus Washington, D.C., inside this data set. So a GIS is not just a digital map. It's a digital visualization of a database. Inside this table are a whole series of attributes. For example, we've got population data, we've got ethnicity, and historical data as well. Here's the historical data. Populations through the decades, going back to 1790 and extending up through 2010. That means we can map any one of these variables in a variety of ways. So, let's go ahead and double click on there. And up pops our layer properties. The Symbology tab is what we want. Right now we're mapping all the states as a beige single symbol. What we want though is to map quantities. Let's pick the variable that we want to map. How about 2010 population? Okay, looks good. Alright, there's our quick map of 2010 population. So a choropleth map is one way I can make this data come alive. Another way though is instead of a graduated color map, I could make a dot density map. So I'm going to scroll down. I've got the same list of variables that I can pick from, and I'm going to go ahead and accept the defaults there, and let's say I want to change those colors a bit. I simply change the color right here. Maybe that color. Okay, and now I've got one dot for every 800,000 people. I can start seeing some patterns by adjusting this. How about 1 dot for every 100,000 people? Ah, interesting. So this is another way to visualize data. How about a pie chart map? Okay, no problem. Pie chart. Let's say we want to map 2010 population as a pie chart. The size we want to vary according to a population figure. So I'm going to vary the size using a field. The field is population 2010. Maybe I want to bump down the size a bit. I can always change it later if I don't like the results. Aha! So now I do have another way of visualizing the data. I can see California and Texas, Illinois, New York standing out, Florida, for example. So that's another way of visualizing my data, is with a pie chart or any other kind of chart. I could make a bar chart or a line chart or any other kind. Okay, let's change it back to single symbol again. Okay, now let's go ahead and change the classification method. Remember we were in quantities before and we mapped on 2010 population? This is where we were a little while ago. Let's say though that I don't want this default classification method. What is the default method? It's the George Jenks natural breaks method. Let's go ahead and look at the distribution of the data. This is where the class breaks are, these blue lines. And these gray bars indicate where my data sets actually fall. I've got a big range of data here. 563,000 for Wyoming, up to 37 million for California. So I've got a big range. Maybe natural breaks isn't the way to go. Maybe quantile is better. Quantile puts the same number of observations in every category. If I have a 5-category map and approximately 50 states, plus District of Columbia, I'm going to have 10 observations in every one of these categories if I select quantile. Let's go ahead and do that. Okay, interesting. So now I've got a quantile map and I can pick out the 10 most populous states right there. Let's say I don't want to vary these colors the way they are. I'm going to go ahead and change the color scheme. Let's say I want something like this, where darker means more. Ah, okay. Maybe that's a little easier to visualize. Another thing I can do is classify. How about standard deviation? Okay. Looks like the mean of the state populations, if I look up here, is 6 million, just a little over 6 million. And there's the median and the standard deviation. The sum of all the state populations in 2010, 308 million, which is the sum of all of the polygons in that table we looked at earlier. Okay, I'm going to say all right now. So now I've got states in yellow here which are close to the mean. Then I've got these states in this sort of brownish color that are below the mean, and then of course I've got other states that are between 0.5 and 1.5 standard deviations above the mean, and then states that have the population that falls over 1.5 standard deviations above the mean. Some other easy things we can do is, let's go ahead and change the classification method back to quantile. And let's say I only want 2 categories, 2 classes. Okay, so now I have state populations from 563,000 to 4.3 million, then 4.3 million all the way up to 37 million. Now I've got 2 category map, but let's say I want the breaking point to be something that I define. So I'm going to go ahead and adjust the range here. Let's say I want states under 1 million in population. And then states over 1 million in population. I want states that are in this first category to be 1 million and less, and then over 1 million. Okay, so there's my map. Now, there are other states here that we're not looking at, right? There's Alaska and there's Hawaii. One last thing to point out is that the G part, which is the map, and the I part, which is the table behind the map, as we saw earlier, that table, are linked. So if I select some states on the map, for example, like this, let's say I'm interested in the Great Plains. So I'm going to click on these states right here. Okay, super. Now let's go to the attribute table. And just the states that I have selected are in the table right here. So what I can do is I can go to any of the fields in here and look at, for example, population in 2010, and I can get statistics on that. 5 states, minimum 672,000, maximum 3.75 million. I've got the sum, which is just under 10 million for these states, the mean and the standard deviation. And that's for population 2010. What about for the year 2000? In the year 2000 was 9.2 million, the sum. What about in 1950? 6.7 million back then. Conversely, we can select things in the table and have them appear on the map. So if we go back to our table now, and then we're going to clear selection, so now we don't have anything selected. And let's say I'm interested in these states right here. Let's say I'm interested in Missouri, Oklahoma, and Kansas. Okay, so I've selected them in the table. You probably know what's going to happen if I go back to the map. Yep, those 3 states are selected. So the table and the map work together. What's selected in the table is reflected on the map. What's selected on the map is reflected in the table. So they work hand in hand. You can also link tables together for even more powerful analysis. So let's summarize. What have we done? We've added data, we've symbolized data, and we've asked some questions of the data. As you can see, it's really easy to change what you're mapping, the fields that you're mapping. It's easy to change the classification method. It's easy to change the number of classes. It's easy to change the colors. And by doing so, you are on your way to analyzing the spatial patterns of your data.